Welcome back to topic 45 for Algebra 2, Properties of Radicals and Solving Radical Equations. In part 4, we're going to learn how to solve equations with rational exponents, as well as solve a word problem. So, as we know, rational exponents can be rewritten as radicals, so it's only fitting that we also learn how to solve equations involving rational exponents. In our example here, we have x squared plus 5x plus 5 to the 5/2 power. Now, in order to undo this 5/2 power, what we need to do is raise both sides to the reciprocal power. Now, the reciprocal of 5/2 is 2/5. So we're going to raise both sides to the 2/5 power. On the left-hand side, it will simplify just to the power of 1. So we'll be left with x squared plus 5x plus 5 equals, now 1 to the 2/5 power is 1. Another way that we could simplify that is, remember, it is the 5th root of 1 squared. Now the 5th root of 1 is 1, and 1 squared is 1. Now we have a quadratic equation here, so we can set it equal to 0 to solve for x. We'll get x squared plus 5x plus 4 equals 0. Now we can factor. What are two numbers that multiply together to get positive 4, but add to get 5? It's x plus 4 times x plus 1. So using the zero product property, x could equal -4 or -1. Now again, here we're going to check to make sure that we do not have any extraneous solutions. If we plug in -4, we have -4 squared plus 5 times -4 plus 5 to the 5/2 power equals 1. -4 squared is 16. 5 times -4 is -20 plus 5 to the 5/2 power equals 1. If we simplify in our parentheses, 16 minus 20 is -4, plus 5 is 1. So 1 to the 5/2 power is 1. Again, that's the same thing as saying the square root of 1 raised to the 5th power, which is in fact 1. Let's try the other value. Plugging in -1, so -1 squared plus 5 times -1 plus 5 to the 5/2 power should give us 1. -1 squared is 1. 5 times -1 is -5 plus 5. In our parentheses, 1 minus 5 plus 5 is just 1 to the 5/2 power equals 1, which also works. So for this example, we have no extraneous solutions. Both of our values of x work. Let's try another example. X plus 18 to the 3/2 equals x minus 2 cubed. Now again, we want to get rid of the rational exponent, so we're going to raise it to the reciprocal power. Even though on the right-hand side we have it raised to an exponent, it will reduce. So the reciprocal power of 3/2 is 2/3. Remember, reciprocal is we're going to take the fraction and flip it. Now using the product of powers, 3/2 to the 2/3, that simplifies to just x plus 18. And x minus 2 cubed to the 2/3. The 3 in the numerator reduces with the 3 in the denominator, and we're just left with x minus 2 squared. On the right-hand side, we can multiply this out. So we'll have x plus 18 equals x squared minus 4x plus 4. Now, in order to solve for x, we're going to set it equal to 0. So I can subtract 18 from both sides, as well as subtract x, and get x squared minus 5x minus 14 equals 0. Now I can factor, and 0 equals x minus 7 times x plus 2. What two numbers multiply together to get negative 14, but add together to get negative 5? Using the zero product property, x could either equal positive 7 or negative 2. Now let's check to make sure none of these solutions are extraneous. Plugging back into the original equation, if we plug in 7, we have 7 plus 18 to the 3 halves equals 7 minus 2 cubed. 7 plus 18 is 25. And 7 minus 2 is 5 cubed. Now 25 to the 3 halves, that is the same thing as the square root of 25 cubed. And the square root of 25 is 5. So 5 cubed equals 5 cubed, or in this case, 125. That one works. Let's try the other solution. Negative 2 plus 18 raised to the 3 halves power equals negative 2 minus 2 cubed. Negative 2 plus 18 gives me 16 to the 3 halves, should give me negative 4 cubed. Now 16 to the 3 halves, that is the same thing as the square root of 16 cubed. Now again, because we're dealing with the principal root here of 16, the square root of 16 is positive 4. Does positive 4 cubed equal negative 4 cubed? Well, think about it. Positive 4 is 4 times 4 times 4, which equals positive 64. Whereas negative 4 has negative 4 times negative 4 times negative 4. We have an odd number of negatives, so my answer will be negative 64. So here, negative 2 is extraneous, because 4 cubed does not equal negative 4 cubed. Finally, we're going to deal with a word problem. Woohoo! So the body surface area, also known as BSA, of the human being is used to determine doses of medication. The formula for finding BSA is BSA equals the square root of h times m divided by 3,600, where h is the height in centimeters and m is the mass in kilograms. A doctor calculates a particular dose of medicine for a patient whose BSA is less than 1.9. If the patient is 160 centimeters tall, what must the mass of the person be for the dose to be appropriate? So first we're going to write our inequality. Now, because we know that the height of the person is 160 centimeters, we're going to plug that in for each. So 160 times m divided by 3,600 is going to be less than 1.9. Now, in order to solve, what we're going to do first, the index here is 2, so we're going to square both sides. Now 1.9 squared is 6.1. So 160m over 3,600 is going to be less than 3.61. We can multiply both sides by 3,600. and get 160m is less than, now 3.61 times 3,600. That simplifies to 12,996. Now we have a one-step inequality. We can divide both sides by 160, and m is less than, when I simplify that, 81 and 225 thousandths. So the mass of the individual must be less than 81 and 225 kilograms, remember, because that is my unit here, for the dose to be appropriate. And that is part 4 of topic 45 for Algebra 2, Properties of Radicals and Solving Radical Equations. Thank you for watching.